Today I will talk about Granger causality in time series analysis. This is part of my series of lectures on cause and effect modeling. This is my lecture outline. First, I will give introduction to Granger causality and vector autoregressive model. Then I will give an example in Python code of Granger causality. Granger causality is an econometric test used to verify the usefulness of one variable to forecast another variable. Granger causality only provides information about forecasting ability. It does not provide insight into the true causal relationship between two variables. A variable is said to Granger cause another variable if it is helpful for forecasting the other variable, and it is said to fail to Granger cause if it is not helpful for forecasting the other variable. In particular, one should use Granger causality testing when one is interested in forecasting performance and not the theoretical model behind the forecast, and when the data is stationary. VAR stands for Vector Autoregressive Model. It is a multivariate time series analysis. VAR with lag 3 model with two variables x and y have two equations. So these are equations where one variable depends on previous three lags of another variable and previous three lags of self variable. To test if Granger causes, we need to determine if any lags are statistically significant in our model. So the coefficients, if these coefficients are statistically significant, if coefficient of any one of the lag is significant, then it means there is Granger causality. And we do this using walled test as we do in regression analysis. VAR model are a generalization of the univariate autoregressive model and comprise one equation per variable in the system. So since we have two variables x and y, so we have two equations in this model. The right hand side of each equation includes a constant and lags of all the variables in the system. In other words, a vector autoregressive model is a multivariate time series model that shows the relationship between current observation of a variable and past observations of itself and other variables in the system. In the context of the VAR, a variable fails to Granger cause another variable if its lags are not statistically significant in the equation for another variable. Past values aren't significant in predicting the future values of another variable. These are the assumptions of vector autoregressive model. The error terms has a conditional mean of 0. The variables in the model are stationary. Large outliers are unlikely, and there is no perfect multicollinearity. Now, Python code example. So these are the libraries for generation of data. We will generate a time series data using stats model, ARMA process method, and we also need date time library. First of all, we create a NumPy array of coefficients. These are the coefficients of autoregressive component. These are the coefficients of moving average component, and we create an ARMA process. Then we slightly alter the variables, and then we add a date component, and finally we make it as a data frame. And we set the dates as index. So this is our data frame with two variables x and y and dates as index. And there is no null value. And this is the plot of our variables. This is the time series plot of two variables x and y. Then we divide our variables into test set and train set. Test set comprises of last 100 data points. Then we test for stationarity. This is the AD Fuller test, where null hypothesis means time series is not stationary. Since the p-value is 0.83, it means that our time series is not stationary. This is KPSS test. Here, the null hypothesis is different from AD Fuller. Here, p-value is 0.01. Hence, our time series is not stationary. So we get a difference of our time series, both the variables x and y, and this is the difference series and it is stationary now. Then we try VAR model with lags 1 to 15, and these are the AIC, BIC, and other results of lag 1 to 15, and the lowest AIC is of lag order 8, 0.043, followed by lag order 9, 0.043. Then this is our result of our model. So these are the coefficients of various lags. So lag 1 to 9, model has selected as 9 significant lags. And this is for equation for x. Because we have two equations. This is the equation for y variable and this is the equation for x variable. As we have seen that the number of equations are equal to number of variables in the model. Then we do the analysis of residuals, and it is okay in our case, and lag order in our case, optimal lag order is 9. Then we do Granger causality test. This is our Granger causality test. And then we do forecasting. So we do forecasting on the basis of VAR model. So this is the forecasted straight line, and the actual data points are these, and this is our forecast. So we can predict one variable on the basis of lag of self variable as well as lags of another variable. So this is all about Granger causality. Thank you very much.